Hello guys, welcome back to our Beach Day lessons. In this lesson, we're gonna, solve basically the homework, which is basically implementing this function with 8 minimum terms using a 4 by 1 max. Okay, we solved it using 8 by 1, and here is, another approach to implement it, basically using a 4 by 1 max. Okay, so as we did in the lecture, we divided the truth table into four possible, four divisions basically, because we have now in the 4 by 1 max, we have 2 bits for the selection. And we connected the selection bits to A and B. And since we do that, so the rest, which is C and D, will be basically constructing the input functions here, I0, I1, I2, I3. I mean, I0 will be a function of C and D, I1 also function of C and D, I2 function of C and D, and I3 is function of C and D. Okay. Or probably will be, because sometimes, like I3 here, it become just constant equal to 1, independent of C and D. Okay. I0 is just a function of D. Okay, not C. So this is a general, a concept that generally they will be a function of C and D, but some of them might be constant or might be a function of subset of these leftover variables C and D. Okay. So based on these four divisions, we discovered that I naught is just equal to D. I1 is C bar D bar or C nor D, whatever you like. I2 is CD or C and D. And I3 is basically constant equal to 1. Okay. So here is a design. So the design should be, a box like this with 4 inputs and 1 outputs. And basically what's inside the design is that thing here. All such, such stuff will be inside here. Okay. So here is a VHDL code for it. So first we define the entity, the box, basically, the 4 inputs and 1 output. Then we need some internal signals. One signal is basically C nor D, this signal in here. And another signal CD, to represent C and D, I mean. Then my mux 4 to 1 package is basically has 2 inputs and 1 output. The first input, which is the selection, the input, I'm sorry. Here's the input, it's just 1 input, but it's 4 bits. So standard logic vector. And S is another second input, it's 2 bits. It's a single input, I mean, but 2 bits. And the output, 1 output and also 1 bit. No arguing that. So I defined 4 signals, as I said, CD and C nor D for these two, S and I to represent the selection and the input, the inputs of the 4 by 1 max. CD is basically C and D. Yeah, really easy. C nor D, it's, the name speaks. So C nor D. Or C bar D bar if you would like, that's fine. C bar and not C and not D. Whatever you like, both are the same. Then I will be the concatenation of these 4 inputs. And the order is really important here. So the most significant bit is 1, which is number 3. That's why it's written in the beginning. Bit number 2 is CD. Bit number 1 is C nor D. And finally bit 0 is just D. Okay. And the S, and again the order is important, it's a concatenation of A and B. And A is the most significant, that's why it's written, in the beginning. Then B, which is the least significant. Then you instantiate a mux here, a mux 4 to 1 from the package that you included in the beginning, and just pass the internal signals that you have to that mux. So the mux needs I, which is 4 bits. I is 4 bits, a concatenation of 4 bits. S, which is 2 bits, and F, which is just 1 bit. Okay. The test bench is really easy as well. Okay, we did this many times. Here we have 4 inputs A, B, C, D. Remember, you are testing this design, which has inside it this mux and NOR gate and AND gate. So for this design to be tested, we should test at all possible values of A, B, C, D. That's what we have done. So I changed it. So ABC will have 4 counters. Each one is a standard logic, okay, which is changes from 0 to 1 because basically it's a binary variable that takes only 0 or 1. So we have 4 nested for loops like this. Okay, one for A, one for B, one for C, one for D. Okay. And here is the run. I ran it already before the video. So let's look at the truth table and try to validate this. So if let's take it 4 bits by 4 bits. So we have in the beginning 0, 1, 0, 1. So 0, 1, 0, 1. Perfect. Then 1, 0, 0, 0. 1 and 3 zeros. 1, 0, 0, 0. Perfect. Then 0, 0, 0, 1. 3 zeros, then 1. So the 0, 0, 0, then 1. Good. Finally, we have 4 ones. So 1, 1, 1, 1. Of course, here the rest here is basically the same as the last stage. This is basically 16 cycles, but I ran it for 20. That's why we have extra 4 cycles. Okay. That's it, guys, for this. It's really easy one. Okay. Thank you very much for watching this video and see you in the next lesson. Bye-bye.